Okay, got me? Got me? Okay, cool. Thank you. My only personal note, so it's 20 minutes. Go, go, go. So my only personal note is I work at McKinsey Digital Labs, which is part of McKinsey & Company, and it's kind of like a startup accelerator for, we use open web technology for enterprises. It's like the best of both worlds, a cool place to work, I hack on JavaScript all day, and we're always looking for great people worldwide, regardless of location. All right, we're going to move really fast, but if you want to go in depth, I've got some training slides on my blog. If you're at ngConf, chances are you've at least seen promises. They're those weird things that you have to extract your data from when they come out of $HTTP, right? So why do they exist? If you've heard of them, you've probably heard that they're about async, which is true. But that significantly understates their overall usefulness. Really, they're designed in a way that lets them be about the bigger, more general idea of uncertainty, about being able to crystallize uncertainty about time, about space, about user-based issues, and almost anything into a nice, neat package, put a bow on it, and give it a super useful API that provides us with this gorgeous interaction pattern so you can reason about and make decisions about uncertainty throughout your application. And they're about helping you try to make the most of your brain when dealing with uncertainty. Promises make engineer brains work better, zombie approved. Okay, so even though promises are about way more than async, the truth is that it is what justifies their existence in the first place. So let's talk async. In the beginning was the Word, and the Word was callback. And the callback was meh. Callbacks have strengths. Look, they do the job. They make non-blocking I/O possible in the first place, and everybody knows how to use them. But they don't scale. They lead us towards huge monolithic handler functions that try to do everything all at once, and an attitude towards async that it's something that you want to simplify and do as little of as possible and just get it out of the way so that you can go back to doing synchronous, predictable, easily modelable kind of stuff. So when you start trying to stack a complex operation with callbacks, things get ugly and nested and complex and unreadable really quickly. We haven't even put anything into these handler functions yet, right? And they're already a mess. See this shape forming here on the left? You know what the shape is called? It's the Pyramid of Doom. We need to do everything right now in the Pyramid of Doom because in a second, all of our data is going to be gone. Forget about coming back and picking up later where you left off, and forget about that code being intuitive and readable and clear and maintainable. And if you do invade the Pyramid of Doom and try to implement something that does let you leave off the middle of the pyramid and come back later, you're going to start building boilerplate like this to cache state variables and outputs and add either timers or events so that you can trigger downstream actions later. It's a mess. It works, but it can work. But good luck with interoperation with other modules you didn't write. Good luck with passing sequenced instructions back and forth between your scopes, let alone the ones that don't even exist yet, like controllers that aren't up and can't listen for events. And then try doing that with all 4 of the tasks from that Pyramid of Doom that I just showed you, and you get this. And mind you, all of this junk doesn't even include any error or success handlers yet. This is just what you have to be able to talk reasonably about whether these 4 async functions have fired yet, whether they've returned yet, and whether you can do anything useful with their output yet. And none of this code is actually doing anything. It's just a bunch of imperative-style housekeeping that's hard to keep track of and maintain, and even harder to reason about and extend. So, promises. Let's be clear first. Promises are not a technical innovation in the JavaScript execution engine. They don't make anything happen more quickly. They don't execute async operations with different native code. They're all about the brains of programmers. It's the same reason we do automated testing and TDD and talk about principles like single responsibility and least surprise. The promise pattern is about making engineers more efficient, enabling us to reason about async sensibly. It allows us to look at async stuff, visualize it, and uncertain stuff in general, visualize it, and write efficient code as if it were predictable, consecutive, synchronous operations. And to link those operations together into virtuous cycles or flows. So if all that's true, the naive understanding of promises needs to go out the door. Promises are not simply syntax replacement for callbacks. There wouldn't be any point in promises if that's all they did. Used right, promises are a qualitative change, a fundamental shift in how we compose and plan for uncertainty and sequencing. So how about an example? How about if instead of all that boilerplate I just showed you, what if you could just declare what you want to have happen? That you want a bunch of uncertain things to happen in a certain sequence based upon some other things that are themselves uncertain. How about that? Welcome to declarative async and uncertainty with promises. Instead of you writing all this boilerplate, just sequence 4 async operations across your application and be able to come back and interact with them later, all you need is this. This is how the promise pattern sequences things and provides self-awareness about what's going on. It knows when it's allowed to move forward between steps. It keeps everything in order. And it can be decomposed. We can decompose that chain of operations I just showed you incredibly easily just by storing references to the promises for each stage of the sequence. The promises are the variables on the left. These actions will fire in the same order as the previous simpler example, but now we can start inserting additional actions later, whenever and wherever we want from any point in the middle of this sequence using the data that comes out of those operations. It's like having DVR for your async operations. We can even pass those references, in addition to going back and grabbing them later and doing what we want with them, we can even pass them into other contexts of your applications. And this is critical, without those contexts needing to know anything at all about the process that generated the promise, because promises are themselves an API that abstracts all of that away. And if you need parallelism, if you want to have 3 of our 4 operations run in parallel instead of in sequence, and then have the 4th one kick in only when all 3 are done, this is all you need. Okay? Either you write all of the imperative boilerplate from before and state variables and other junk, and then set a timer to check every few milliseconds to see if they're all done yet, or use events if you're lucky and that even works for you. All that, or you do this one line that replaces it all. That's composition with promises. That's the pattern they allow you to work with. So if that's the overall pattern, what in a nutshell are the component promise objects themselves? I promised a certain metaphor in my talk title, even though I'm not going to do all the details here. But at root, understand that a promise is basically just a mailbox. It's a special, standardized repository where you can stash the data that outputs from an operation. It has a property representing the completion and success state of that operation, and it has utilities that leverage all of that knowledge into further downstream operations whenever you want. And all your functions everywhere can have a key to this mailbox and can know what they need to about it so that they can know what's going on. And you can even pick this mailbox up and carry it around with you by reference into different contexts of your application, providing your components with all the benefits of async, but without them needing to understand the implementation. Then, on top of the promise, there's this thing called the deferred. Lots of folks get promises, and they're like, yeah, but the deferred, I'm not so sure. It's really straightforward. Once you think of the promise as the mailbox, the deferred then is simply the postman. No, not that endless tribute to Kevin Costner's Vanity, thank God, but just a real live, actual postal worker. The postman is the only one who's allowed to assign you a new P.O. box, or create the promise, or put new packages into the P.O. box, thus resolving the promise. Or, inverting the real-life example a little, let's pretend the little flag on the side of the mailbox means you have mail, it's ready to pick up, instead of that you're sending mail out. The postman would be the one who'd be allowed to raise that little flag and showing you that you're ready to go, you have mail, come get it, and do something with it. So with the deferred, you're the postman. You can create and administer the mailbox. Without the deferred, you're a customer, a promise consumer. That's it. That's the main idea. But the pattern of use is more significant than the individual promise objects themselves. Alone, They are, in a way, just syntactic sugar. But together, they can change your whole approach to composition. And they can sure as hell reduce the amount of boilerplate code you write, guaranteed. So now, remember, promises are not just for async. Time and place uncertainty is certainly the conventional context for promises. But there are other kinds, especially user-related. A given AJAX request is actually semi-predictable within a range. Users, though, are totally unpredictable. You have no idea when or if your user will get around to doing certain things or in what order. So take advantage of promises as a way to encapsulate and abstract that kind of sequencing as well, even though it's not execution engine asynchronousness as we mean that term. Using promises, you can build custom async interfaces that are API-driven, that are totally understandable to all consumers around user uncertainty as well as any other kind. Which gets us finally to Angular. Angular is an example of what happens when you start thinking in promises structurally, when you bake them right into the fabric of the application and use them as a way to model process flows and to make sure that the right things happen in the right order at the right time so that the different parts of your application can hand off those flows seamlessly and customize them and so that you can think about them. And so if you think that Mishko and Vojta and Igor and Brian and Brad and all the other cats on the Angular team are pretty smart, if you're here, in other words, then follow their example and get way into promises. Because Angular is way into promises. So here's sort of an 8-step program to using promises in Angular. Step 1, when you get started with promises, you're just a consumer. Okay? You're grabbing them from the built-in services that return promises like $HTTP and very notably $timeout and $interval. And I'm going to stop using the dollar. Angular has gone to the trouble to make all of the most fundamental async functions into promise generators so that promises can be the seamless, common API, there's that word again, an API for all of your async. It's as simple as this. If HTTP returns a promise, all you have to do is store a reference to it. Forever after, as long as you hold the reference, you can run other operations against it. Step 2, when you're ready to get a little tricky, try $resource. Okay, the implementation of resource has shifted a little recently, but here's the skinny on 1.2 and after. Resource works a little differently than HTTP. It's promise generating, but it's a useful but perhaps confusing pattern. $HTTP.get returns a simple promise. But calling the initial get method on a resource type that you've defined returns a resource object. That resource object has a promise. It's not a promise, it has a promise as a property. So to chain from that resource with then, you just use resource object dot promise, and then you can do all the other same stuff with it that you would with just a plain old regular promise. The weird, cool thing about it is that the reference is circular. If you unwrap a resource's promise property, what you get back from inside of it is the original resource, which of course has a promise, which you can unwrap. So the resource has a promise, which has a resource, which has a promise. Truly, it's turtles all the way down. Complicating things further, the other instance methods on a resource, like save, they don't modify that original promise. Instead, they return new bare promises for the state of the individual operations rather than modifying the resource itself. So step 3 is such a big, worthwhile feature that one of the release candidates for the version of Angular it debuted in was named promise resolution. By using the resolve property in your route definition, you get several huge benefits that you just don't want to be operating without. Number 1, the route won't change until your data has been obtained and you have everything you need in order to render the view. No flicker, nothing looks broken, that's it. It all just works. And so your controller, number 2, gets to be totally, completely ignorant of all of the implementation details. It doesn't even need to know what a promise is. It doesn't need to know how to unwrap it or how to check the success of the operation. Route Provider does all of that for you. All the controller gets is the second it's born, it gets this data object that's finished, that's ready to go, injected at creation time. So it gets to be totally implementation independent, which is the holy grail for controllers whenever possible. And so then in the controller, all you have to do is inject the name of the property, my data in this case, and you can do whatever you want with it, like bind it to the scope. Step 4, let's just be aware that it's something related to what I just showed you. In Angular 1.2, this changed. For a while there, you could place a promise object on the scope, and then Angular would automatically extract the value from it and inject that into the view. You will see that in old documentation. Beware of it, it doesn't work anymore. Okay? Reading the repo, it seems it was just too much magic for people. It made consumers of promises less aware of how they worked and how to use them. It complicated using parse. It was also slow. So just know that it used to be there. It's not anymore. Don't trip over it. And inject your promises via resolve instead, or just unwrap them. Unwrapping is easy. Step 5, start creating your own promises with Q. Not just necessarily about traditional async, but about the other stuff we talked about, user uncertainty. Any other question that you need to know the answer to before you move forward. If it doesn't boil down into a nice, handy, convenient Boolean, and sometimes even if it does, try wrapping it in a promise and see if that doesn't make it easier to proceed. Check out those detailed slides I mentioned for more details on how to do that. The third-party libraries, step 6. Start noticing how many third-party implementations like UI Bootstrap Modal also take advantage of promise flows in very, very virtuous ways. If you define one of these modal instances which carries a promise as soon as it's created, you immediately define a handler with modal instance.result.then down here at the bottom. Before we've even had time to do anything in that modal, before all that user uncertainty kicks in, we've already created a handler for whatever we're eventually going to return from the modal dialog as the result object. We don't know when or even if there will be a return, but we're ready for it, we can reason about it, and we can easily then just take that whole thing after somebody's done and pass it off into other contexts, to other consumers, and let them deal with it as they want. Note that UI Modal also uses a copy of the Angular resolve property, just like the Angular router does, to ensure that the view in that modal won't be rendered until the data is ready. Step 7. Promises that you can reference without needing to care if they even exist yet, let alone if they've resolved. Normally, you need to know that a promise has at least been instantiated before you can start interacting with it. Otherwise, you get undefined. But because Angular services are instantiated lazily, as needed, and persist throughout the application lifecycle, all you have to do is wrap a service around that promise, and then you can reference it anytime from any location, provided you simply inject the service into that context, a controller, let's say. The caller of the promise, the controller, need not know or care anything about the implementation or when that promise gets built. Now, outside of Angular, if you want to do this, or if you want multiple promises inside one service, you can do the same thing with just a simple getter function. Okay, step 8 is master level, HTTP interceptors. They're these awesome things that allow you to mess around with every single AJAX operation that goes in or out the door, all from a single location. And they're promise-based in both directions, in and out, request and response. Promises, again, aren't just something for async output. They're part of the modeling of the whole cycle from the beginning, and thus you can chain from even before an async operation kicks off. So this example is stripped bare and oversimplified just so it fits on screen. It shows a way to trigger automatic universal loader screens in your app whenever something async is going on. With promises, we're able to interact with the stream of low-level instructions Angular uses down in the plumbing, and we can even conveniently pause the stream while we wait for something to happen simply by returning a promise that isn't resolved yet. You want to do validation, you want to check that a user session is still open before you then issue the request. No problem. Compose and insert a single promise object in the right state, and you get that control right in the guts of Angular's operations. We're going to skip this for time. Best practices, use service-oriented architecture. Think of promises as the beginning of your life cycle or the flow, and decompose your handler functions. And if you thought perhaps that promises are this wacky thing that's just out there that you don't really have to use, previously, promises were a library feature. Now, native promises in the browser are not only in the ECMAScript 6 spec, they're in release in Chrome 32 as of this week. Okay? Yeah. Thank you, guys. Anyone who's here who had anything to do with that. It's a little different than the A+ spec, but I think in a good way. So this means that whatever the other browsers do, even if they lag, we can rally around the API, we can start getting used to it, we can shim it, and you can make this API for uncertainty that you can count on and work into your stuff. Oh, and the new DOM APIs are even going to return anything async that comes from this point on, as I understand it, will return a promise. You will have to deal with them. Thank you very much. I'm at aboutme/XML. Thanks.